Chapter 5, Gases. There's a picture from your book. Why does the cork pop out of the champagne bottle? Ever thought about that? Because there's gas pressure built up from the carbonation in the champagne, and it causes the cork to go flying out. So we're going to study gases. Some important things to understand about gases. Gases are composed of particles that are moving around very quickly, very fast in the container. These particles are going to move in straight lines until they collide with something. Because most of, like, the air in this room is a gas, but most of it is empty space. And the particles in the air are extremely tiny, and so they're just going to go in a straight line until they run into something, because that's how physics works. Then they bounce off. And if we were able to take a snapshot of the particles, we'd see that there's a lot of empty space in that gas, a lot of just plain nothing. Well, if you throw a ball against a wall, it exerts a force, right? And I don't know if you've ever accidentally thrown the basketball against the metal garage door too hard and dented it. That happens. Somebody did that in my house. It exerts a force, right? Well, we can think of gas molecules as being a little bit like balls, and when they hit the wall of the container, they exert a force. Now, it's not a very big force, a very small force, but there's a lot of gas particles, and so we have a lot of collisions, and the result is pressure. Pressure is defined as force exerted per unit area. So pressure equals force divided by area. If you have a very small area, the same amount of force is more pressure. So if I'm laying on the floor and my daughter Emily comes over and lays down on top of me, the force she is exerting is her weight. The pressure is her weight divided by the area, which is going to be relatively large if she's just laying down on top of me. So is that a lot of pressure? No. If she stands on my back on one foot, now the area is much smaller, the force is the same. The pressure is greater, right? What if she put on a high heel shoe and stood on just the heel? Ooh, that's more than would leave a mark. That would actually go through your skin. Old-fashioned linoleum, a modest-sized woman, just like a 100-pound woman wearing very tiny heels, you can actually poke holes in linoleum wearing heels because the force of 100 pounds over 1/4 of an inch squared is really large, right? So it's important to remember this relationship that force divided by area. If the area is greater, the pressure is less. If the area is smaller, the pressure is greater. So the gas pressure is a result of the constant movement of the gas particles. So you can imagine in this room these little balls just zinging across, and it goes over there and it bounces off the back wall, and it comes over here and bounces off the hood, and it comes over here and hits me in the forehead. And they also collide with each other. But we have all these gas particles, and they're colliding with the surfaces around them. So that is the pressure, that force divided by the area. The pressure is going to depend on a few different factors. The number of gas particles in a given volume. If you have more particles, you're going to have more collisions, right? So that would be a higher pressure. The volume of the container. If the volume is bigger, what happens to the area over which those particles are hitting? Does it get bigger or smaller? Larger volume container has larger area. That reduces the pressure. The average speed of the gas particles is going to affect the pressure. If the gas particles are moving fast, let's think about, I think I mentioned to you the gas, solid, and liquid states of students, right? If we were to pretend that we were in the gas state right now, we would be running around the room. If we're running around the room, are we going to collide with each other more than if we're walking slowly? Yeah. Particles moving faster collide more frequently. More collisions, more pressure. The other thing that happens is if the particles are moving faster, if two people are walking towards each other and run into each other, just a bump, no big deal. If you're running towards each other and collide, that's a much bigger force, isn't it? So when the particles are moving faster, each impact is greater as well. So there's actually two things contributing to the increase in pressure with average speed of gas particles.